in this video, we're going to spend some time talking about polynomials and end behavior. And the first thing I need to formally do is talk about the definition of a polynomial. So you'll see it there. F of x equals a to the n times x to the nth power plus a to the n minus 1 times x to the n minus 1 plus, and it keeps going in that fashion until you get to a1x plus a sub 0. I know that looks like a mess, but what's going on here is the n values, okay? Not just this first n value, but this n value, n minus 1. There's a 1 here, and there's not an n value here at the end. Those are all exponents, and those exponents are whole numbers. So they are 0 and larger, and they're integers. So you could be 0, 1, 2, 3, 4, 5. What they are not is negative numbers or fractions. So make sure you realize that. You can't have a polynomial with an x to the negative 5 power, or a polynomial with an x to the 1/3 power. Okay? The next thing you see is a sub n. Now a sub n, these are called coefficients. These are the numbers being multiplied by the x to the power. And those could be real numbers. They can be nice tidy numbers like 2, 3, 4, -8, or they can be fractions, or they could be irrational numbers like the square root of 2 or pi. So there's not a lot of restrictions. They're not imaginary numbers. That's the only thing they're not. But these can be any really real number values, whereas these exponents, again, have to be whole numbers. Each one of these, and let me highlight this in a different color, how about pink? Each one of these is called a term. Okay, so polynomials could have one term or more. Okay, can't have 0 terms, but you could have one term or more. Look at this mess that I've done from highlighting. So let's do some erasing here. All right, and then finally, the next thing I need you to know is that the n, now this time I don't mean just all the exponents, I mean literally the n one, which is the highest value one, that guy right there, that's called the degree. And again, the degree is the highest exponent. So let's look at a few problems where we identify how many terms we have, what the coefficients are, and what the degree of the polynomial is. So for our first polynomial, or is it a polynomial? Let's talk about that first. Notice it says, is this function a polynomial? Why or why not? Okay, and then we can discuss what the degree is, how many terms it has, and that sort of thing. So if we look at f of x right here, is that a polynomial? So first of all, let's check the exponents. We've got an x to the 5th, an x to the 3rd, an x to the 1st, and an x to the 0 power. Notice those are all whole number exponents. The numbers in front, the coefficients, they're all real numbers. So yes, this is a polynomial. Okay. On the other hand, g of x, you've got a 4th root, 3 times the 4th root of x squared minus 2x plus 1. That is not a polynomial. Okay. Any radical is not allowed, and really a radical is a fractional exponent, so that's not allowed at all. H of x, is that a polynomial? It is, even though it has these parentheses. You could expand that by multiplying x plus 2 times x plus 2 times x plus 2 and distribute the -5 in, and you would have a polynomial because it's all x to some whole number power. You're not going to have a fractional exponent. You're not going to have a square root in the problem. You're not going to have a negative exponent. So this is definitely yes. I know k of x, the red guy right here, equals 8. Seems like it's not a polynomial, but actually it is a polynomial with one term. The degree is 0 because the highest power is x to the 0 power, and that's it. r of x is what we call a rational function because it's in fraction form, and it is a polynomial in the numerator. It's a polynomial in the denominator, but when you take a polynomial, divide by a polynomial, you do not have a polynomial anymore. So this is no, not allowed. And the last one is also not a polynomial because of the x to the 1/2 power exponent. And remember, we're not allowed to have fractions as exponents in a polynomial. For the next problem, I'm asking how many terms does the polynomial have, what is the degree of the polynomial, and what is the leading coefficient. So that's a new thought, the leading coefficient. So let's talk about that. And by the way, all of these are polynomials. So this first one has 1, 2, 3, 4, 5 terms. The degree is the exponent that's the highest, 5, so this is a degree 5. And then the leading coefficient. Now the coefficients, we have -3, -2, 6, and -7. You do take the signs with the coefficient, but the leading coefficient is the one, not necessarily that it's first, but is the one being multiplied times x to the highest power. So the leading coefficient comes from the same term that gives you the degree. All right, so on the next problem, k of x equals 8. We saw that on the previous page. This is one term. The degree is 0 because this is like times x to the 0 power, and then the leading coefficient is just 8. Okay? Now, the next problem, h of x, okay, is -5 times x plus 2 to the third minus 1. Now, how many terms does it have? We really can't answer to that without multiplying that all out. So I don't want to answer that question because I don't want you to have to FOIL all that out. You can imagine how many terms it would be. If you do x plus 2 to the third, it's going to give you an x to the third in there, an x squared in there, an x to the first, and a constant. That's going to give you 4 terms, but again, I don't want to ask that question about this one because I don't want you to have to expand that. Now, what I do want to ask is the rest, though. What is the degree? Again, it's not expanded, but we know if we expanded this, it would be an x to the third would be the highest power, so this is a degree 3. The leading coefficient would be if we raised this to the third, and then multiplied it times the number in front. So 1 to the third is 1, times -5 is -5. So the leading coefficient would be -5. And again, the terms, we would end up with 4, but I don't need you to get caught up in that. What I do need you to know how to do is find the degree and the leading coefficient because we're going to use it for something else shortly. Okay, next problem, g of x. Now, it's got 1, 2, 3, 4 terms because it is expanded, so it's easy just to count the terms. The leading coefficient, be careful, the x to the highest power is right over here. These are not always in descending powers order. A lot of times they're easier to work with in descending order, but this is not this one. And look, I didn't pay attention either. It's not x to the 4th. What is it? It's x to the 7th. That's the highest exponent. Let me fix that for you. So 7 is your degree. And then the leading coefficient is always the coefficient associated with a degree, so -8 is your leading coefficient. And finally, the last one. Now again, the number of terms here, we don't really know that would be what that would be. We could guess that it's probably going to be, well, let's don't do that yet. We can do that at the end. But this is not expanded, so I don't want to ask you the number of terms. What I do want to ask you is the degree, okay? Now, it's not going to be to the 4th, okay, because you've got x squared to the 4th. Matter of fact, this is all multiplication here. So you have an x to the first right here that you're going to multiply by an x to the third. You see where I'm getting that x to the third? It's a first times this 3, and then that's going to be times an x to the 8th because you have this 2 times this 4. And then when you're multiplying bases, remember you add the exponent. So that's going to give you, if you expanded all this, an x to the 12th power. Okay, so this is going to be a degree 12. So they're a little bit trickier finding the degree if they're not expanded. Like here, it's just x to the 1st to the 3rd, and 1 times 3 gave me a degree 3. I didn't have any other thing I was multiplying by. But here, I mean, we're multiplying a lot out here. This is an x to the 1st times an x to the 3rd, because the 1 to the 3rd power, times an x to the 8th. And you do 1 plus 3 is 4 plus 8 is 12, so it's a degree 12. The leading coefficient would be the number in front, negative 3, times this 1 is negative 3, times this 1 to the 3rd is still negative 3, times this 1 to the 4th is still negative 3. So the leading coefficient would be negative 3. Alright, I've got something important to show you here. It's called the leading coefficient test, also known as end behavior. And this is a really interesting, easy test you can do by just simply looking at a polynomial and determining its degree and leading coefficient, which is really what we did on the previous page. We also counted the number of terms on some of them. But for a polynomial, if you can tell me what the degree is and what the leading coefficient is, then you can quickly tell what the ends of the polynomial are doing, and we call that end behavior. So let's take a look and see what we're talking about. So if the polynomial degree is even, so if the degree is a number like 2, 4, 6, 8, 10, and the leading coefficient is positive, so any positive number, so 2, 4, 7, pi, all those are positive numbers. If both of those conditions exist, then the left side of the polynomial is pointing upward, and the right side of the polynomial is also pointing upward. Notice I say it's going to positive infinity. And so look at this. Now, y'all know over here to the right, this is just the function f of x is equal to x squared. So that's got an even degree and a positive leading coefficient. And notice the left side is pointing upward and the right side is pointing upward also. Okay, pretty interesting, huh? Now let's take a look at the second part of the test. If the polynomial is still even, but the leading coefficient this time is negative, okay, so you might have a even degree 2, 4, 6, 8, but the leading coefficient is a negative 5 or a negative square root of 2 or negative 1/3, okay? Then the left side this time is going downward and the right side is going downward. So the function that I have listed over here for you is f of x is equal to negative x squared. This is just an example, but notice the left side is going down and the right side is going down. Okay, and these are graphs you were already well aware of, okay, but now we've got this end behavior to back it up, and we can apply this to other polynomials in graphing that we don't know what the graph looks like. Alright, so let's take a look at another example or another case of our leading coefficient test. If the polynomial degree is odd, okay, so I'm saying the highest exponent is like 1, 3, 5, 7, or 9, and the leading coefficient is positive, and we have an example of that to the left. Say, for example, f of x is equal to x to the 3rd. Notice again, the degree is an odd number, and the leading coefficient is positive. Look what the left side is doing. It's going downward, and the right side is going upward. Okay, so again, notice that the left side is pointing downward and the right side is pointing upward. And that only leaves us one more case that we could take a look at, and that case is if the polynomial degree is odd and the leading coefficient is negative. So we're talking about highest degree of 1, 3, 5, 7, 9, but the leading coefficient is negative. And the example that I give over here to the right is f of x is equal to negative x to the 3rd. And you'll notice that the left side is going upward and the right side is going downward. And if we look at that, again, the left side over here, notice that's up, and the right side over here is downward. And this is something that you just simply need to memorize. Now, instead of memorizing that it's even, you know, then the left is up and the right is up, as long as the leading coefficient's positive, a couple of things may help. One thing is remember a function that you already know the situation. Again, a parabola is an x squared, and that has an even exponent. And if there's a positive 1x squared, they're both pointing upward. Everybody knows a parabola with a leading coefficient goes upward. And if it's a negative x squared, it goes downward. Okay, so remembering something that you already know. Or another option is to remember that even means they point in the same direction. And if it's even and positive, it's upward. And if it's even and negative, it's downward. And odd is pointing in the opposite direction. So you can either have it memorized that x to the third, everybody knows what an x to the third graph looks like, that if it's positive x to the third, it's up on the right and down on the left. And if it's negative x to the third, it's reversed. Or you can remember that odd means opposite, and if the leading coefficient's positive, it's like the graph is increasing. Positive means increasing, which is down on the left and up on the right. Or negative, you think decreasing, which is up on the left and down on the right. But no matter what, odd, they're pointing in opposite directions. Even, they're pointing in the same direction. All right, we want to describe the end behavior of the graph of each function. So let's look at our first function, f of x. F of x equals negative 3x to the fifth minus 2x to the third plus 6x, subtract 7. Okay. Now, two things we need to know. We need to know the degree of the polynomial, and we need to know the leading coefficient before we can even answer the question of what is the left side doing, what is the right side doing. Well, the degree is the highest exponent, so check all your terms. Yes, 5 is the highest exponent, so it's a degree 5. And the leading coefficient is the coefficient of the term that gives you the degree, okay? And we have an odd degree and a negative leading coefficient. And remember, odd and negative, remember odd means opposite, so the left and right are pointing in opposite directions. Negative means it's like a decreasing graph. So it means the left side, notice here, is upward. I'm just going to put up, and the right side is downward. Or you can just go back and look at your list that says, and it's the, let's go back and look, it is the fourth case with an odd degree, negative leading coefficient. The left side's going to negative infinity. Positive infinity, which is upward, and the right side is negative infinity, which is downward. Okay, let's look at the next case, g of x. The next problem, h of x, is non-expanded. Okay, so you would have to imagine doing x plus 2 times x plus 2 times x plus 2. But you know that's going to give you an x to the third. The rest of the terms don't matter. The highest is going to be an x to the third times 2 is going to give us a 2x to the third. So the second one here is a degree 3, and then the leading coefficient is 2. Now, it's not as simple as the one above, where you can just look at the highest power and the number in front. But, again, to expand x plus 2, you would get an x to the third times this 2 in the front. So, again, this time we're odd, but the leading coefficient is positive. Remember, odd means opposite. So I know these are not going to be the same direction because odd is opposite. But when the leading is positive, it's like it's increasing. And the left side is going downward. And the right side is pointing upward. Third example, g of x, 4 plus 16x to the third minus 8x to the sixth plus 2x to the fourth. Remember the degree of this thing. This is expanded, by the way. This is a degree 6. And the leading coefficient is negative 8. So we're talking an even degree with a negative leading coefficient. Now what's significant about even is they're pointing in the same direction. So I know they're both going either up or down. Well, if the leading is negative, they're both going downward. So the y value is going to negative infinity. And it's easier just to say down. Most people can picture what I mean by down on the graph. And when you get in a calculus class, they're going to say f of x is going to negative infinity. All right, and then our last example, Remember, we expanded that in our minds earlier. We had an x to the first times an x to the third times an x to the eighth. And when you add those, because you're multiplying bases, you get a degree 12. So we did that previously in the video. And then if you distribute that 2, then your leading coefficient is going to be 2. Now what matters is you're even with a positive leading coefficient. Even means they point in the same direction, and positive means they're both going upward. So as x goes to negative infinity, f of x is going to positive infinity, and f of x is going to positive infinity. So I hope that helps. In the next video, we're going to talk about zeros.